It's afternoon, and I'm so sorry that yesterday I couldn't upload any videos because I have studied yesterday, but I didn't felt it relevant to do one. But today, it might for me I needed a revision, so I'm doing it for myself. This subject is strength of material, and it's unit one. It's not unit one; it's unit two. Unit one, you have to have the idea about the unit one, and but it does not connect with each other. It's not bridging, but without having a proper understanding of unit one, you cannot jump into like five directly, isn't it? So for that, okay, I'll just get started. From the bending moment in this chapter is my bending moment in shear force. So first of all, there are several terms and notation that you need to have to look it by yourself, and I'll just revise whatever I feel is relevant for myself. Types of support. Supports are required to generate a point reaction to resist loading condition. Like support reactions are classified as follows. Like we have a simple free rocker support. In roller support, there only will be one vertical reaction will be generating. Likewise for the pin support, like you can think of like door or windows. It's a hinge. In that you will see that there will be a horizontal reaction and a vertical reaction. There will be two reactions developed. For the simply supported beam, there will be a horizontal moment, there will be horizontal reaction, vertical reaction, and there will also moment will also be generating, I guess. And for the incline roller support, suppose this is my incline roller support. In that, how you solve it, there will be in components. This is my by solving the components. This is my VH, this is my VP, and there will be a resultant reaction which will be equals to VH square. आपको पता है ना पाइथागोरस थ्योरम से क्या होता है कि P square equal to H square plus B square होता है, तो उसका ही उससे हम लोग V equals to VH square plus BP square. If this यहाँ का square root it goes to the right hand side, then it will turn into root. So roller are placed at an inclined on and vertical restraint achieved. Like इसके बाद guided roller support like dams होता है. Guided roller support में क्या होता है कि there will be a vertical reaction and there will also be a moment. Moment will be generating. Like you have seen the door shutter in the shops, they have like ऊपर में भी roller support होगा, नीचे में भी roller support होगा. Like link support, inner support, and the reaction in the direction of the cable is offered. इसमें types of beams होता है. Simply supported beam up to, it can be classified based on the type or the number of the support. Like simply supported, if you say simply supported beam, it's like up to 250 feet, and if it's a continuous beam, the span will be more than two support will be called as continuous beam, and the span will be greater than 250 feet. And for cantilever beam, this is my cantilever beam. It is used for offers a large high deflection. Propped cantilever beam, it's used for the large span. Propped cantilever beam or cantilever beam, you can see the difference in a propped cantilever beam. At the end, you'll be providing with the support roller support, and it may be also overhanged. It may be also provided in the middle so that the length can be, if the length is too long or too much, too jada. I know about that, but I'm so sorry. I don't want to explain it. I don't want to read it sometime. I just want to cry out. But no, I have to study. You can see that this the fifth one we have is beamed with the internal hinge. Beam with the internal hinge means ये देखो आपका ये hinge support है, और right side में आपका ये this is your roller support. Internal hinge यहाँ पे provide करेगा, but यहाँ पे moment will be equals to 0. So ये क्यों provide किया है बोलने से, so that to avoid the deflection of the beam. यहाँ पे ये सब points note down किया. If you like overhang beam again, we have like single overhang and double overhang. Single overhang में we have only this, but in double overhang में you will be provide जितना like double. सबसे important क्या है analysis of the beam. To analyze the beam, we'll need to have the understanding of this equation DOI. Generally, you can see that equilibrium, you'll have to have the idea about the equilibrium equation and then reaction, number of the support reaction of the beam. Generally, we know that we have a three equilibrium equation, that is summation fx equal to 0, summation fy equals to 0, summation mx equals to 0. This is my internal hinge. You can see that internal hinge. If the internal hinge is present over the span of the beam, it gives an additional equilibrium condition. I hope I'll explain it in the coming topic. In all of this, you will get it. Condition such as on the basis of the structure can be classified into, इसमें ना हम लोग structure को हम classify कर सकते हैं statically indeterminate structure and statically indeterminate structure. Statically indeterminate structure is what? अगर if your DOI is greater than 0, the structure is indeterminate. If your DOI is less than 0, then the less than or equals to 0, the structure is determinate structure. If your DOI is greater than 0, then the structure is stable. If your DOI is less than 0, the structure is unstable. DOI is equals to degree of indeterminacy is equals to R minus R, where R is the number of the support reaction and R, big R, capital letter R is the number of equilibrium condition, which we have is 3. So now we'll see some examples of this statically determinate structure and indeterminate structure. Suppose we have a simply supported beam. This is my roller support, this is my hinge support, and we know that we only have one vertical reaction in the roller support, and in the hinge support we'll have the vertical reaction as well as horizontal reaction. So from here, this R is equals to 3, which is fixed. So our and small r is also 1, 2, 3. So from here we're gonna get DY equal to R minus R is equals to 0, which is a stable indeterminate structure. These all are simple. You can see that the prop cantilever beam and these things Okay, I'll explain you. I'm gonna explain which I have said here. I'm gonna explain it here. If suppose you have a propped cantilever beam, it says that there will be an internal hinge. Because of this internal hinge, there will be one more addition of the equilibrium equation. There will be one more one numbers of increase in one number of equilibrium equation, like r equals to 3. It's basically 3. So because of this internal hinge, we'll add 1. So it's going to be 4. So this is my fixed beam. There will be 3 r, and here again it's roller 1 VA. So from here we're gonna get 0, which is statically stable and determinate. And state it is. I'm gonna deal with the type of the loading now. Okay. This, you can see that this is a UDL, uniformly distributed load. This is my UDL, uniformly varying load. This is my moment. This is also my moment. You can see that this is my UDL is my W kilonewton. UDL. This is my point load. This is first one is we have a point load, which is W kilonewton, and this is my simply supported UDL, kilonewton per meter. What I need to explain here is, so you can see that this is my internal hinge, and the moment is this moment is what anti-clockwise. Notice, yeah, m equals to 2, going to be 2 pl. This one is for this. And for this 2pl L2, where is this? Yeah, for this I'm going to solve it. Yeah, so moment it will act here. So from here, moment is what? Load into perpendicular distance. P is our load and L1 is our perpendicular distance. And similarly for this case, you can see that this is my P load into perpendicular distance, load into perpendicular distance, load into perpendicular distance. Yeah, maybe PL होगा. इसके बाद 2 equals and opposite forces. You don't have to understand this. इसको क्या करना है? और calculation of the reaction. अब कैलकुलेशन ऑफ द रिएक्शन कैसे कर सकते हैं? सपोज ये हमारा एक यूडीएल है, ये आपका यूडीएल है, तो हमको क्या करना है सर? फर्स्ट हमको टोटल लोड निकालना है। ये यूडीएल को फर्स्ट हमको पॉइंट लोड में कन्वर्ट करना है। वी नीड टू कन्वर्ट इनटू पॉइंट लोड। सो दिस इज माय डब्ल्यू, यूडीएल इज माय डब्ल्यू kilonewton per UDL is my W kilonewton per meter. To convert it into point load kilonewton, we just have to multiply with the length, so it's going length get cancelled, and we are left with this W kilonewton. वही क्या है देखो, load into distance W kilonewton, and remember that WL equals को आप कैपिटल W लिख सकता है. And moment is total load into perpendicular distance. Total load WL into perpendicular distance means CG. अगर यहाँ से तो ये लोड यहाँ पे लग रहा है तो perpendicular distance L/2. Always remember that ये ऐसे L होगा तो इसमें L/2 पे एक्ट करेगा, क्योंकि ये रेक्टेंगुलर कंसिडर करना है. WL/2 हो जाएगा. इसके बाद अगर ये है आपका, तो यहाँ पे आपको क्या करना है? आप इसको एरिया का बेसिस में भी कर सकते हैं. लाइक देखो, ये हो गया आपका, तो आप एरिया जो क्या हो जाएगा, हाइट इंटू लेंथ W इंटू L हो जाएगा. इसके बाद टोटल लोड या मोमेंट हो जाएगा, लोड इंटू परपेंडिकुलर डिस्टेंस WL/2. आप इसको ऐसे करो या फिर यहाँ का जैसे करो, सेम ही होगा. अगर लेकिन आपका बेयरिंग लोड हो जाएगा तो यू कैन सी दैट ये आपका बेयरिंग लोड के लिए है. एंड वी नो दैट अगर ये आपका ट्रायंगल है तो यहाँ से ये आपका एपेक्स से 2L/3 पे एक्ट करता है और बेस से L/3 पे एक्ट करता है, और ये आपका हाइट है W kilonewton per meter. टोटल लोड इक्वल्स टू हाफ इंटू दिस इज माई total load is going to be my area, isn't it? Half into base into height it is, and the moment is going to be total load into the perpendicular distance. Total load is this, and the perpendicular distance will act 2L/3. So from here it's going to be 2L square WL/3. Similarly for this, इसको आप जो क्या कर सकते हैं कि this is my W1, तो यहाँ से यहाँ तक W1 हो जाएगा, ये आपका W2 है, तो this distance will be W2 minus W1, and you know the formula for this trapezoidal. You can solve it in using this formula, और आप इसको divide करके भी, मतलब सेक्शन में भाग करके भी कर सकते हैं. So this is going to be figure 1, this is going to figure 2. ये figure 1 में आपका triangular हो जाएगा, figure 2 में आपका rectangular हो जाएगा. इसके बाद solve कर सकते हैं ऐसे, आपको जैसे चाहो. Calculation for the reaction. Calculation for the reaction of object. हम actually there are three equilibrium equation आपको पता है. Summation f equal to 0, summation f equal to 0, summation x equal to 0. Suppose it's our simply supported beam. The load is point load is acting. Point load without UDL. VA होगा, HA होगा, VB होगा, we know that. And summation f of x and horizontal load, no horizontal load. So H is going to be equals to 0. Summation f of y is equals to 0. So हम लोग लिखेगा VA. आप इसको sign convention को, if it's acting from the downward direction, you can take it positive. If it's from acting from top, you can take it as negative. So VA into VA. VA is going to be this VA, and this is my W plus VB equals to 0. So VB equals to 0. अब हम मोमेंट को कैलकुलेट करेंगे. मोमेंट को हमने क्या बोला था? लोड इनटू परपेंडिकुलर डिस्टेंस. So from left to right we are taking the moment. So VA into 0. VA because no यहाँ पे कोई लोड नहीं है, डिस्टेंस नहीं है, लोड इनटू परपेंडिकुलर, तो VA into 0. इसके बाद प्लस W into L लोड इनटू CG, टोटल लोड डिवाइडेड बाय CG. तो यहाँ पे क्या आते हैं? W into L/2 माइनस VB into L, VB into टोटल लेंथ. यहाँ से इधर हो जाएगा. तो जब आप इसको पूरा सॉल्व करेगा तो यहाँ से W/2 निकलेगा. यहाँ से आपका VB इक्वल्स टू W/2 निकलेगा और VA इक्वल्स टू W/2 निकलेगा. बस अगर आपका ये सिंपली सपोर्टेड बीम है तो आपको क्या करना है? बस यहाँ पे समेशन f of y में क्या करना है? ये UDL में तो इसको पॉइंट लोड में कन्वर्ट करने के लिए यू नीड टू मल्टीप्लाई विद लेंथ एंड VB. इसके बाद यहाँ से करने के बाद यहाँ से आपका आ जाएगा W/2. दिस W/2 इज माई WL/2. हाँ, आप ये W/2 मत सोचो, क्योंकि कैपिटल लेटर को हम WL भी लिख सकते हैं ना, उसी तरह से. और बहुत थक गया, आई एम वेरी टायर्ड माय माउथ. सो आज के लिए यहीं पे बाय बाय. थैंक यू.